Imagine looking at a mirror from a sort of sideways angle and seeing a ball on the other side of the room. Now look at it represented from above in a simple diagram. Obviously, you see the ball because its reflection is visible in the mirror. We might think that we see things because our vision is looking outwards, but in fact we see things because the light is coming from the object to our eye, so we have to draw the arrows in that direction. So in our diagram, we've got two light rays. One is going to the mirror, the second one from the mirror to our eye. The first one is called the incident ray. Incident comes from Latin and means falling on. So the incident ray sort of falls on the mirror. The second is reflected off the mirror, so it's called the reflected ray. The direction the reflected ray comes off the mirror is not random. The angle it bounces off at is the same angle that the incident ray reaches the mirror with. If this is 40 degrees, this one is 40 degrees. But this is not how we usually do it when describing reflection angles. Firstly, you need to understand the word normal. It's not used here the way you might be used to. Normal comes from another Latin word that means at a right angle. Here, in this example, the normal is an imaginary line that's at a right angle to the mirror. When we talk about angles and reflection, we describe them relative to the normal. So here, you can see that our incident ray hits the mirror at an angle of 50 degrees from the normal. This is the angle of incidence. And because the ray reaches the mirror at exactly 50 degrees from the normal, it will reflect at exactly 50 degrees from the normal. This angle is called the angle of reflection. The most important thing you must learn about reflection is that the angle of incidence is always equal to the angle of reflection. It's because of this rule that all rays of light bouncing off a mirror reach your eyes in an organised way and allow you to see an object clearly. But if this is true, and it is, I promise, why doesn't every flat surface behave like a mirror? If you compare the surface of a wooden floor to a mirror, you'll notice that you don't see a clear reflection in the floor. The light rays reflecting off the mirror reach the eyes in an organised way because of the law of reflection, but the light rays reflecting from the wood floor are being scattered in different directions by the surface, giving an unclear image. And you might think the law of reflection doesn't apply to the wood, but it does. If you could zoom in really close to the surface of the wood, you'd see that it's uneven. Each ray still bounces off the bit of surface it reaches with an angle of reflection that is equal to the angle of incidence. And the result is rays bouncing off in different directions, preventing you from seeing a clear image. Very smooth surfaces, like mirrors, result in what we call specular reflection. But rough surfaces result in what is known as diffuse scattering. In both cases, the law of reflection is obeyed.